In that quiet and silent world, where the human mind is incomprehensible and the secrets of creation are hidden in darkness, a new face. A completely different face than anything the world has ever seen. For many years, scientists and engineers worked hard, all focused on one important goal: to create a machine that could see the dawn of the world. The odds are astronomical. What if this eye could reveal the birth of stars, the formation of constellations, and clues to the origin of life? The problem becomes apparent as the truth approaches. The world held its breath as the James Webb Space Telescope, JWST, the most advanced and complex telescope ever built, prepared to launch into the void, carrying the hopes and dreams of a generation of explorers. The JWST, often hailed as the successor to the Hubble Space Telescope, has revolutionized our understanding of the universe since its launch. This extraordinary machine, a marvel of human ingenuity, has provided an unprecedented view of the cosmos, uncovering mysteries and revealing sights never before seen by humanity. Equipped with cutting-edge technology, the JWST has allowed scientists to peer into the farthest reaches of space, exploring galaxies, stars, and planetary systems formed billions of years ago. The story of the JWST is not just a tale of scientific achievement, but a narrative of perseverance, innovation, and the relentless pursuit of knowledge. To understand the importance of JWST, it is important to understand its predecessor, the Hubble Space Telescope. Launched in 1990, Hubble gave astronomers the first clear images of distant galaxies, nebulae, and stars without the effects of planetary obscuration. Hubble has made many contributions to science, from helping to determine the rate of the universe's expansion to observing the collision between comet Shoemaker-Levy 9 and Jupiter. Its deep images, capturing light from galaxies billions of light-years away, are the first we've ever seen. Despite its successes, Hubble has limitations. The first reflector, 2.4 meters in diameter, has a low light-gathering capacity, and the instruments are designed for the ultraviolet, visible, and near-infrared parts of the spectrum. As astronomers push to the limits of our knowledge, the need for a new telescope is clear, one that can observe in the infrared spectrum, that can see in the universe's dust clouds and observe the universe's first galaxies. The idea for the James Webb Space Telescope was conceived in the early 1990s, before Hubble reached its full potential. Named for James E. Webb, NASA's Apollo-era director, JWST was billed as the next big observatory, a telescope that would look back beyond Hubble's time and capture the light of the first stars and galaxies formed after the Big Bang. The design of JWST was a major technical challenge. Unlike Hubble, which orbits the Earth at an altitude of 570 kilometers, JWST is in the second Lagrange phase, L2, about 1.5 million kilometers above the Earth. This location provides a stable environment with little disturbance from Earth's heat and light, but means that the telescope cannot be operated or adjusted by astronauts. JWST needed a mirror larger than Hubble to observe the faint, distant objects it was designed to study. The solution is a segmented mirror made of 18 gold-plated hexagonal beryllium segments, with a diameter of 6.5 meters. The telescope had to be folded up to fit inside the Ariane 5 rocket that launched it, opening only when the telescope reached its target. To add to the complexity, JWST will need a solar shield to block heat and light from the Sun, Earth, and Moon, and to keep the telescope's instruments from operating temperature is only a few degrees above absolute zero. This sunscreen, about the size of a tennis court, has 5 layers of a special material called Captain, which can withstand extreme heat. After years of planning, time and cost, JWST will be launched on December 25, 2021. The launch will be a spectacular event watched by scientists and astronauts around the world. The Ariane 5 rocket carried the telescope into space, and over the next 30 days JWST will begin a series of difficult and precise deployments. The telescope's sunshield is the first major part to be released, a process that involves hundreds of machines and thousands of parts that work at their best. It is impossible to die in this mission. After the sunscreen is properly applied, the reflective parts begin to open and adjust. The process took several months, as each part had to be placed to the precise nanometer. By mid-2022, JWST will have completed its deployment and alignment, and the instruments will be ready to begin recording data. The first images released to the public are stunning. The telescope's ability to see in the infrared showed the world in a new light, with great clarity and detail. One of JWST's primary goals was to observe the first galaxies that formed after the Big Bang, more than 13 billion years ago. These galaxies are so distant that their light has been stretched into the infrared due to the expansion of the universe, a phenomenon known as redshift. Hubble can only look at these ancient objects, but JWST's infrared capabilities allow it to see them in unprecedented detail. In its first year of operation, JWST made many discoveries. One of the most important is the discovery of galaxies a few hundred million years after the Big Bang. These galaxies are larger and more evolved than previously thought, challenging current theories of formation and evolution. Scientists have long believed that the first galaxies were small and grew by merging with other galaxies. However, the JWST observations suggest that some galaxies are forming faster than previously thought. This discovery caused astronomers to rethink their models of how galaxies form and grow. JWST also took pictures of the world's structures that had never been seen before. For example, the telescope revealed important details of the cosmic web, the vast network of filaments that connect galaxies across the universe. These filaments are made of dark matter and gas, and are the scaffolding on which galaxies form and evolve. JWST's observations of the cosmic web have provided new insights into the superstructure of the universe and the role of dark matter in its creation. JWST has revolutionized our understanding of star formation and evolution. Stars appear in dense clouds of gas and dust that block out light. However, infrared light can penetrate these clouds, allowing JWST to observe star formation in unprecedented detail. One of the telescope's first targets was the Orion Nebula, a star nursery located about 1,344 light-years from Earth. The JWST images revealed hundreds of young stars, some still trapped in their birth clouds. These observations provide new insights into the nature and evolution of stars, including the processes that lead to the formation of planetary systems. In addition, JWST has also observed the final stages of stellar evolution, capturing stunning images of dying stars and the nebulae they form. These observations shed light on the processes that govern the end of a star's life, including the formation of white dwarfs, neutron stars, and black holes. One of the exciting things about the JWST program is its ability to study exoplanets, planets that orbit stars outside our solar system. Telescope instruments can analyze the atmospheres of these distant worlds, looking for signs of habitation and life. In its first year of operation, JWST made several discoveries of large exoplanets. One of the most notable was the discovery of LHS 475b, a planet located approximately 41 light-years from Earth. The planet is about the size of our Earth and orbits the star in just 2 days. JWST's observations revealed that LHS 475b has a thick atmosphere, possibly water vapor, carbon dioxide, or methane. JWST has also discovered other exoplanets with different atmospheres. Some of these planets have thick, cloudy atmospheres rich in methane and other hydrocarbons, while others have light gases dominated by hydrogen and helium. These observations have provided important information about the diversity of planetary systems and the conditions that could support life. One of the most pressing questions in astronomy is whether life exists elsewhere in the universe. Although the JWST cannot detect life directly, it can look for biomarkers, chemical signals that indicate life. For example, the detection of oxygen and methane in the atmosphere of an exoplanet may indicate the presence of biological processes. JWST's ability to study exoplanets has opened a new era in the search for life beyond Earth. As the telescope continues to observe other planets, it will provide valuable data to help answer the age-old question: are we alone in the universe? In addition to its studies of distant galaxies and exoplanets, JWST has captured images of some of the most beautiful and mysterious objects in the universe. One of the most interesting is the cosmic tarantula, a large star-forming region in the Large Magellanic Cloud, a satellite star in the Milky Way. The cosmic tarantula, also known as 30 Doradus, is home to some of the most massive stars known, some with more than 100 times the mass of the Sun. JWST images of the region show a barren landscape of wind, dust, and young stars, revealing the violent process of star formation. Another amazing image taken by JWST is the Pillars of Creation, a prominent star-forming region in the Eagle Nebula. JWST's infrared observations of the formation columns have revealed new information about the formation of these towering columns of gas and dust, as well as the young stars that form within them. These images provide valuable information about the processes that drive star formation and the evolution of star nurseries. As JWST continues its mission, its discoveries will change our understanding of the universe in ways we have never imagined. The telescope's ability to see deeper into space and back in time is already beginning to challenge current theories and raise new questions about the universe. From the birth of stars and galaxies to the search for life on distant planets, JWST is poised to unlock some of the universe's deepest mysteries.